Alright, so let's begin with 14. Excuse me. There is part 1 to this video, so make sure that you've watched part 1 before you continue on with this part. Alright, so we are continuing to see that we need to get x by itself, and we have 1 log. Alright, now in a previous problem we had talked about you could pull this 2 down to the front, but then you'd have to divide by 2, and 7 does not divide by 2, so it would probably be easier for you to leave it and just rewrite it right off the bat. So we'll say 4 to the 7th, we're just rewriting in exponential form, equals x squared. Alright, if I take 4 to the 7th, that gives me 16,384. And then all I have to do is square root. So I get x equals 128. I wouldn't take the negative square root because remember when we talked about this, we don't plug in negative numbers. Okay. All right, number 15. You will notice that you have 2 logs. Both of those logs have a base of 10. So therefore, to condense this down into 1 log, I notice that I am adding. So that means I would multiply the x and the x plus 9. So I'll keep the log base 10. I have to distribute that, so it's x times x is x squared. And x times 9 is 9x. And I've got equals 1. Now that I'm down to 1 log, I'll rewrite this in exponential form. So this would be 10 to the 1st equals x squared plus 9x. Make sure you take all of that. You can't just pick part of it. You got to have the whole thing. So again, you should notice that you have an x squared and an x to the 1st, and then this would just be 10. So I'm going to go ahead and subtract the 10 so that I get a trinomial all over here together. So I get x squared plus 9x minus 10 equals 0. And since I have a trinomial, I want to factor that. Alright, remember a minus and back means you have 1 plus and 1 minus. In order to get an x squared, you would need an x and an x. And 2 numbers that multiply to make 10 and subtract to make 9 would be 10 and 1. Since there's a plus in front, the bigger number, which is 10, we'll go with the plus. Set those 2 factors equal to 0. So I would subtract 10, so I get x equals negative 10. And I would add the 1, so I get x equals 1. So the deal is that this is a negative and this is a positive, and we talked about how we cannot plug a negative number in here and take the log of it. We don't take logs of negatives, so therefore negative 10 would be an extraneous solution, so the only solution that counts would be x equals 1. Alright, number 16. Excuse me. Alright, so you notice that you have 2 logs, but here's something that you're going to forget about. This is taking the log of the x plus 3 over 10. This log is only taking the log of x. So I want to move this away from both of my logs. So I'm going to subtract it. Alright, so that's going to leave me with log x plus 3 tenths plus log x equals negative 1. Alright, so now I notice that I have 2 logs that have the same base. Excuse me. They both have a base of 10. So that means that I can put them together as 1 log base of 10. You are adding, so that means that you have to multiply the x and the x plus 3 tenths. So I'll distribute x times x gives me x squared. And then x times 3 tenths is just 3 tenths x. equals -1. All right. Then I am ready to rewrite this in exponential form. So 10 to the -1st equals all of this right here, x squared plus 3/10 x. I need to simplify this side over here. 10 to the -1 is 1 over 10. Your calculator will do that for you, okay, if you don't remember the negative exponent rules. Then I have x squared plus 3 over 10 x. So I do notice that I have an x squared and an x and a number, okay? So what I'm going to do is I'm going to go ahead and subtract the 1/10 so that I can get everything on one side. And I know how much you guys like fractions, but this isn't really that bad. And I'm going to show you how to make it better. So I've got x squared plus 3/10 x minus 1/10 equals 0. All right, if you notice, everything has a denominator of 10, except for this. All right, both of these do. So what I'm going to do is I'm going to go through and I'm going to multiply everything by 10. So this would be 10x squared. I would say 10 times 3/10 x minus 1/10 times 10, and then times 10. So every single term gets multiplied by 10. So that's going to leave me with 10x squared plus, if I multiply by 10 and I'm dividing by 10, these two cancel. So that leaves me with just 3x. And same thing here. I'm dividing by 10. I'm multiplying by 10. These two cancel. That just leaves me with -1 equals 0 times 10 is just 0. All right. So now I don't have denominators anymore, and that's really nice. But the problem is that I have a 10 in front. So since I have a 10 in front, we'll do the illegal move. We'll do 10 times -1. So I get x squared plus 3x minus 10 equals 0. I'm going to go ahead and factor that like I would a normal trinomial. Minus and back means a plus and a minus. To get an x squared, I'd have to have x and x. And two numbers that multiply to make 10 and subtract to make 3 would be 5 and 2. Since there's a plus sign in front, the bigger number, which is 5, will go with the plus, and the 2. Now the thing you can't forget is that since you multiplied by 10, you're now going to have to divide by 10 and reduce. So 5 over 10 is the same thing as 1/2. And 2 over 10 is the same thing as 1/5. And if we were just factoring, we would move the 2 in front and we would move the 5 in front. Since we're looking for solving for x, we'll just leave it like that and set it equal to 0. Kind of cuts back on a little bit of work that we would have to do. So if I subtract 1/2, I would get x equals -1/2. And if I add 1/5, I would get x equals 1/5. And we talked about this. We cannot plug in negative numbers for logs. So therefore, this answer is extraneous. And the only one that we count is x equals 1/5. Alrighty. Last page here. So we're going to talk about how we could do this. I don't know why this says number 17 in the homework. We'll just make this number 18. All right. We're going to talk about how we can use tables and graphs to solve exponential and logarithmic equations. So if you will recall from a long, long time ago, all right, we talked about how you could put in this side into your y1 and the other side of your equation into your y2, and then you could figure something out from that, okay? So that's exactly what we're going to do. We're going to have x1, or y1 and y2. So in our calculators. We're going to go to the y equals, and we're going to put in 2 to the 2x, and then the y2, we're going to put in 1024. Alright, and I am looking for when this left-hand side, or the y1, is equal to the right-hand side. Now, normally, if you go to your table, we set this up to where we put in our own values. So let's go back, since this isn't multiple choice, let's go back to our table setup menu, so second window, and we're going to change this independent back to auto. Alright? And this just says my table is going to start at 0 and it's going to go up by 1. Alright, so let's go back to the table. So we're looking for when this y1 is the same as y2. So if you look, this is getting closer, it's getting closer, bam, right there, they are the same, and that is when x equals 5. So your answer is x equals 5. Now could you solve that by hand? Yes, you could. Alright. Alright, so now let's talk about this. We want to know when this side is less than or the same as this side. So again, we'll do y1. This will be y2. And we're looking for when this side is less than or equal to this side. So I go to my y equals. I'm going to clear that out, and I put in log x. Make sure you close that parenthesis so that you know you're done with that part. Minus log 2, close parenthesis, and then we'll be plugging in log 75. So again, we're looking for when this side is less than or equal to this side. So let's go to our table. So it's going to find when it's equal to. All right, so it looks like we're going to have to go up quite a bit. All right, you just have to keep scrolling. This is a shortcut way of doing something, but it also takes a long time for you to actually get up to the part that's the same. So still, left-hand side is still less than that, so we want to find when it's equal to that. We're getting closer. Keep scrolling. Keep scrolling. Getting closer. It would be easier, I think, to just solve this by hand, but you know, sometimes we like to learn different ways so that we can check our answers as well. This would be a good way to check answers from the other part of your worksheet. Okay, so we're getting really close. All right there, 1.8751, 1.8751. And we're looking for when this side is less than or equal to this side. Well, it's equal at 150, and it's less than when your x values are less than 150. So your answer would be, well, when x is less than or equal to 150, that means both sides are less than or equal. All right? So the left side is less than or equal to the right side. Okay, and the last one here. So this would be my y1, and this would be my y2, and this one's going to be a little bit different. Don't you love it when I say that? So we have 2 to the 2x plus 1. Okay, and this side is 256. So we're going to go to our table. And I'm all the way back down here again. So I'm going to go back to my table set menu so I don't have to scroll so much. See how it says when I start at 140? Let's just put start at 0. Okay. Then when we go back to our table, it starts at 0. All right, so if you notice, at 3, we're looking for when these two sides are equal. You got 128 and 256. And then all of a sudden at 4, this side is bigger. So here it's smaller, but here it's bigger. So that means that it's not going to be add a whole number, it's going to be in between 3 and 4. So let's go back to our table set menu, change this back to ask, or I tell you what, let's try something different this time. Let's tell our table that we want it to go by, I don't know, 0.1. Okay? See how it goes 0, 0.1, 0.2, 0.3, so on and so forth. So, and then let's tell it that we want it to start at 3 because we know it's in between 3 and 4. So now I go back. All right. And if you look, 3.1, it's smaller, 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 the same. So at 3.5 is where we get this. So x equals 3.5. So part of this lesson will be you having to remember how to use your table, okay? And it's just really easy to change the settings. Second window. All right, tell it where you want to start. Tell it how far you want it to go up every single time. We don't really like 1, okay? But it's whatever you want to do. All right, but if you notice that it's in between 3 and 4, or it's in between 5 and 6 somewhere, then start at the top and then tell it how far you want it to go. Just go by 0.1 or whatever you want it to do. All right, and then it should be pretty good from then. And that's all I've got for you.